Fuel systems used on Bombardier outboards. Topics include fuel system components, theory of operation, and maintenance procedures. Carburetors will be covered in Module 5, and Evinrude's direct injection will be covered in Module 9. The outboard's fuel system begins with the fuel line, a hose that connects the outboard to the boat's fuel system. Outboard fuel line may be used to connect to a metal through-hull fitting in the splash well or to a portable fuel tank. If the hose is connected to anything other than a splash well fitting or portable tank, it is considered part of the boat's fuel system, and Coast Guard regulations must be followed. Many outboards have a quick disconnect feature that allows the fuel line to be separated from the motor. The hose end of a quick disconnect connector includes an O-ring. If the O-ring is cracked or worn, fuel can leak from the connector, or air can enter the fuel system. Some smaller outboards use dripless fuel line connectors. The dripless connector has a valve that opens when the hose connector is attached. Fuel flow will be restricted if the valve doesn't open completely. Fuel lines are safety-related and vital to the life of an engine, so always inspect the hoses and connectors on every outboard you service. Stiff, cracked, worn, and damaged hoses must be replaced. All hoses used on Evinrude and Johnson outboards conform to strict engineering standards. Special materials are used to resist the damage caused by corrosive fuel additives and the harsh marine environment. Many of the hoses are pre-formed to reduce kinking. When replacing hoses, use only the correct part as indicated in the parts catalog. A diaphragm-type fuel pump is mounted on the outboard's power head. It draws fuel from the boat's fuel system and delivers it to the carburetor or fuel injection system. On two-stroke models, pressure and vacuum pulses from the outboard's crankcase drive the fuel pump. The fuel pump is connected to the crankcase by a short hose or a passage between the fuel pump and crankcase. As the outboard's piston moves up in the cylinder, it creates a low-pressure area in the crankcase. This is commonly referred to as vacuum or partial vacuum. When the pump's diaphragm moves toward the vacuum, atmospheric pressure pushes fuel past a check valve into the pump. When the piston moves down in the cylinder, pressure rises in the crankcase and moves the diaphragm in the opposite direction. This pushes fuel past another check valve and toward the carburetor or fuel injection system. The four-stroke fuel pump works in a similar way, except the diaphragm is moved mechanically by a lobe on the camshaft or crankshaft. If the fuel pump has a removable cover, a filter screen is located under the cover. Inspect the filter screen whenever you service an outboard. Be careful when you install the removable cover. On some fuel pumps, the cover screw threads into a plastic housing. The screw should only be tightened finger tight. Using a screwdriver or pliers to tighten the screw could damage the threads in the housing or crack the cover. Most 40 horsepower and larger two-stroke Johnson outboards use a combination fuel oil pump mounted on the engine. The pump draws oil from an oil reservoir, mounted inside the boat, and fuel from the fuel tank. The pump injects oil into the fuel and pumps the mixture to the carburetors. The fuel oil pump is divided into 4 sections: the air motor, the fuel pump section, the oil pump section, and the sending unit for the no oil warning. Let's begin by examining the air motor. It converts pressure and vacuum pulses from the crankcase into mechanical motion to drive the fuel and oil pumps. Pressure and vacuum pulses from the crankcase enter the air motor chamber through a hose connected to the crankcase. Valves direct the pressure pulses to one side of the air motor piston. When a vacuum pulse is present, pressure is relieved from the opposite side. The pressure difference between the two sides forces the piston to the right, compressing the air motor piston spring. When the piston moves fully to the right, the poppet valve contacts a boss on the air motor cover, opening the valve. This equalizes the pressure on both sides of the piston, and the air motor piston spring forces the piston to the left. The poppet valve shuts, and the cycle repeats. The air motor piston is connected to the fuel and oil pistons by a short stem. As the engine consumes fuel, the air motor pulls the pistons to the right. The fuel piston forces the fuel-oil mixture out of the right side of the fuel chamber. At the same time, fuel is drawn into the left side of the fuel chamber, and oil is drawn into the oil pump. When the air motor poppet valve opens, all pistons move rapidly to the left. The fuel and oil inlet valves shut. The fuel transfer valve opens and allows the fuel piston to move through the fuel in the fuel chamber. The oil pump piston pushes oil past its outlet check valve and into the left side of the fuel chamber, where it mixes with the fuel. Next, the poppet valve shuts, and the air motor begins pulling the pistons back to the right, pumping the fuel-oil mix from the right side of the fuel chamber to the carburetors. The cycle repeats as the engine consumes fuel. This pump features a no-oil warning system to signal the boat operator if oil flow stops. The no-oil warning sender includes a circuit board that counts electrical pulses from the alternator stator and a reset switch. The circuit board counts the pulses from the stator. When the oil piston pushes the oil out, the pressure closes the pulsar switch. If the switch closes before the circuit board reaches its target count, the count returns to 0 and starts over. If the switch does not close before the circuit board reaches its target count, the no-oil alarm activates. Be sure to inspect the remote oil tank on every oil-injected outboard you service. Any water, gas, or other contaminants must be removed before using the outboard. If the tank contains water, consider mounting it in a drier location. If necessary, the oil tank can be installed in a battery box. Gasoline in the oil tank might be the result of operator error. However, it could also indicate a problem with the pump. The hose connecting the remote oil tank to the pump needs to be primed during initial engine installation and after any repair to the oil injection system. With the oil hose disconnected from the engine, pump the primer bulb on the oil hose. Hold the hose end up so all the air rises to the top of the hose. Catch oil from the hose in a container. Continue pumping the primer bulb until all of the air is purged from the hose. Reconnect the hose. Pump the bulb 2 or 3 more times. After servicing an oil injection system, make sure the operator mixes oil with the fuel at a 50-to-1 ratio until you can verify the oil injection system is functioning. Marking the oil level on the tank is a good way to verify the oil is being consumed. You can verify that fuel pump pressure and the fuel-oil ratio are correct by performing simple tests described in the service manual. Problems with the boat fuel system often cause low fuel pump pressure and poor performance. The following procedures for testing the boat's fuel system are described in the service manual. The outboard must be under load during testing. A flushing device alone does not provide a load. Use a dynamometer, test tank, or launch the boat. Install the vacuum gauge and clear line into the fuel delivery hose. Start the outboard. Advance the throttle. Observe the clear hose and vacuum gauge. A good fuel delivery system will read below 4 inches of mercury on the gauge at all times, and air bubbles will not show in the clear line. A high vacuum reading indicates a fuel restriction. Restrictions can be caused by kinked hoses, fittings that are too small, stuck or poor quality anti-siphon valves, or debris on the fuel tank pickup's strainer screen. Air bubbles in the clear hose indicate an air leak in the fuel system. Because fuel may not leak out at the point where air leaks into the system, carefully check all of the fuel system's fittings, connectors, and hoses. A damaged pickup tube in the fuel tank could also be the source of an air leak. This may not cause a problem when the tank is full. However, when the fuel level is at or below the crack, air will enter the fuel system. A vacuum switch is used on many V6 models to warn the operator of a fuel restriction. The switch is connected between the fuel supply and fuel pump, like the vacuum gauge on the boat fuel system test. A restriction in the fuel system will cause a partial vacuum in the fuel line and turn on the switch. The vacuum switch will activate at approximately 6 inches mercury, well above the limit of 4 inches mercury. A partially restricted fuel system usually supplies enough fuel to operate the outboard at slow speeds, so the vacuum switch will not normally activate the warning system at idle. But when the engine is running at high RPM and fuel demand is at its highest, a restriction in the system will limit the amount of fuel flow. When the vacuum is strong enough, the vacuum switch closes and the warning system activates. Most 40 horsepower and larger outboards use an inline fuel filter. When servicing an outboard, inspect the filter for clogged screens, loose fittings, and other damage that could create a leak or restrict fuel flow. Be sure to service the inline filter annually or every 100 hours of engine operation, whichever comes first. The primer solenoid, an electrically operated valve, provides additional fuel to make starting a cold engine easier. Pushing in on the key switch opens the valve, allowing the fuel pump to force additional fuel through the valve into the engine. Pushing the key switch in causes current to flow through the windings of the primer solenoid. This creates a magnetic field that moves the plunger and opens the valve, allowing pressurized fuel to flow through the primer. Turning the red primer knob to the on position will also open the valve. The knob is used only in case of an electrical failure. Under normal operating conditions, the primer knob should be in the off position. Turning the primer knob to the off position will close the valve. Spring tension keeps the plunger valve against its seat. Remember, the primer system relies on fuel pump pressure to move fuel. Unless the engine is running, cranking, or the primer bulb is being squeezed, opening the valve will not provide the additional fuel required when starting a cold engine. Some outboards have a manual primer with 3 modes: off, enriched, and prime. Pushing the manual primer knob all the way in prevents fuel from flowing through the primer. This is the off position. Pulling the manual primer knob out so the red stripe is visible allows fuel to flow from the float bowl through the primer and into the engine. This is the enriched or warm-up mode. Pulling the manual primer knob all the way out forces fuel into the engine. Check valves keep the fuel moving in the right direction. This is the prime mode. It primes the engine for starting. The recirculation system is an important part of the two-stroke powerhead. When the outboard is running, some fuel and oil will settle out of the air-fuel mixture and cling to internal powerhead parts. This is especially true when the powerhead is cold. Recirculation systems pick up this puddled fuel-oil mix and redistribute it in the powerhead. The recirculation system consists of check valves, fittings, hoses, and internal passages. The fuel system is designed and calibrated with these systems working. If the system is not working properly, fuel may accumulate in the crankcase and cause a cylinder to run rich. Since a different cylinder normally burns these fluids, that cylinder could run lean. A good understanding of fuel system components, theory of operation, and maintenance procedures will help you quickly troubleshoot and repair fuel system problems and keep your customers having fun on the water.